I'm Anil Kumar. Welcome to my series on polynomials. We'll discuss the relation between the roots of polynomials in this video. Specifically, we'll talk about the sum and product of the roots. Clear? In case you want to learn from me, you can always send an email on the address given. Also, check our website for the latest updates on our videos. So in short, we'll begin with the polynomials. What are they? If a polynomial is of degree n, it will have n roots. We'll derive formulae for cubic polynomial roots. We'll also have a general formula for roots of polynomials, and we'll take up examples and examination practice questions. In general, a polynomial can be written in the form given here, which is an x to the power of n plus an minus 1 x to the power of n minus 1 plus an minus 2. These are the coefficients, right? X to the power of n minus 2. The degree, you can see, decreases by 1 when we write, right, like this. An is the leading coefficient, and it continues till a constant a is 0. So here, the important terms which we'll generally write is a0, which is treated as a constant, correct, and an, which is called the leading coefficient. Okay. We'll actually derive formula for the roots of n degree polynomial. Sum of the roots x1 plus x2 plus x3 till xn is equal to minus an minus 1 over an. That is, it is the ratio of the coefficients of these two terms. The leading coefficient goes to the denominator, and the one adjacent to it with 1 degree lower, an minus 1, is in the numerator. The product of the roots for nth degree polynomial will have n roots. So product of all n roots will be minus 1 to the power of n times the constant over the leading coefficient, right? So that's an easy way of remembering. Specifically, if you talk about the cubic equation, then in a cubic equation, you expect how many roots? Well, 3, right? So let x1, x2, x3 be 3 roots. In that case, their sum is going to be minus of a2 over a3, where a3 is the leading coefficient, a2 is the coefficient of x squared. The product of these roots in the way x1 times x2 plus x2 times x3 plus x3 times x1 is actually the ratio of a1 over a3, and the product of all the three roots is minus constant term over the leading coefficient, right? You can actually derive this formula from here also, n being odd, minus 1 to 3 power, which is an odd number, will be negative, and therefore you get this negative for the product of the roots, right? We're actually going to derive this formula soon. Now let us see, how do we derive these formulas? We'll actually begin with the roots of quadratic equation. Let the quadratic equation be a2x squared plus a1x plus a0. That's the general form, correct? You can actually divide all these terms with a2, right? So you could also write this polynomial in a way like this, correct? Taking a2 as a common factor. So we get the leading coefficient within the bracket as 1, right? That's the whole idea. And we could write this as x squared plus a1 over a2x. We just took a2 as a common factor, a0 over a2. So any polynomial could also be written with leading coefficient of 1 in this manner, correct? Now, let us say that the roots of this quadratic equation are x1 and x2. Well, the quadratic equation can have two roots, right? Let x1 and x2 be these two roots. In that case, what is going to be the polynomial? Well, the polynomial will be x minus x1 times x minus x2, right? Of course, if you want to keep some coefficient a, you could keep it. But for our general derivation, where we are most interested in the factors form, right, and the relation of the roots, we'll only consider these two factors, correct, as we move along. Now, we can apply the distributive property, multiplying them with x first. So x times x gives you x squared, then x times minus x2 gives you x minus x2. Now we can do the same with the other term, which is x1 times x gives you x1 with the negative sign and x1 with x2, both negative, makes it positive x1, x2. After applying the distributive property, we can actually factor x common, right? So if I factor x common from the center two terms, then taking minus x as a common factor, we get x1 plus x2 within the bracket. And the last term, which is plus x1, x2. Now, let us compare the equation which we wrote, this equation, with what we have got. Let's compare them. Compare the coefficients, right? So if you compare the coefficients, what can you see? Clearly, what we notice here is that the coefficient of x is what? Coefficient of x is minus x1 plus x2, which is the sum, right? x1 plus x2. And that should be equal to a1 over a2. I took the minus side on the right hand side. Do you see that? By comparing the coefficients, you can now relate the roots with the coefficients. You get the idea. The constant term here is what? Well, the constant term is x1, x2, and that should be equal to the constant term a0 over a2. And so we get the product form. So from here, we can say what is the sum and product of a quadratic equation, right? For the roots of quadratic equation, right? So what is the sum and product of quadratic roots? If x1 and x2 are the two roots, then the sum is the ratio of a1 over a2 with the negative sign, and the product is a0 over a2. That is constant over the leading coefficient. So what do you notice here? In both the cases, in the denominator, we always see what? The leading coefficient. Is that clear to you? Correct? So we have derived the formula for relation of the roots in a quadratic equation. Now let's extend this to cubic equations, correct? So now let's talk about a cubic equation. Let the cubic equation be a3x cubed plus a2x squared plus a1x plus a0. Now once again, I would like to write it in a different form. What I'm trying to say here is that I'm taking a3 as a common factor. In that case, I could write the coefficients as a2 over a3, a1 over a3, and a0 over a3, the leading coefficient now being 1, right? It becomes simpler for us to compare the coefficients. Now in this particular case, let us assume that the three roots for this cubic equation are x1, x2, and x3. Definitely, the factored form could be x minus x1 times x minus x2 times x minus x3. Now let's multiply them. So we earlier did this product, x minus x1 times x minus x2, and we got that relation, correct? Applying the distributive property. Now we are going to apply the distributive property between the other terms. So you expand the first two terms and then multiply with the third factor, as we are going to do now. So you get 4 times 2, 2. 6 in all, 8 in all, right? So for each, you get one term. Multiplying with x squared, x, you get x cubed, right? Multiplying x squared by minus x3, you get minus x squared x3. Similarly, multiplying with minus x1, x, you get minus. So similarly, multiplying by x, x2, similarly, now let's multiply x, x2 with the other terms. So you get the two factors, which are x square x2 when you do it with x, and then with x3, you get plus x, x2, x3. Continue this process to get all other factors as shown here. So once you apply the distributive property and expand the three factors, what you get is the equation shown here. Now clearly from here, we can take x squared factors common, right? X factors common and the constant term. So x cubed minus x squared is in three terms. X squared x3, right? X squared x2 and x squared x1. All are with negative sign. So I've taken negative x squared and we're left with x1 plus x2 plus x3. Similarly, taking with x, we get the three factors which are product of x1 x2 plus x2 x3 plus x3 x1 and the constant term x1 x2 x3. Now compare the coefficients once again. So clearly from here, what do you get? Well, the sum x1 plus x2 plus x3 is the ratio a2 over a3 with a negative sign. Do you see that? And that's how we get the first relation, that is to say that sum of cubic roots is always minus a2 over a3. The middle term here is the sum of product of x1, x2, x2, x3 and x3, x1. And that should be equal to a1 over a3. And that's what we have written here as a summary. And the last term, which is the constant term, should be a0 over a3. And since this is negative, we have written negative here. And we get our product of the roots as negative a0 over a3. So in all the three cases, leading coefficient is in the denominator and in the numerator. We have the coefficients a2 and a0, right? a2, a1 and a0 for the three conditions, as you can see. So these are the formulas which we have derived. You can actually continue this process and also see what happens when the power is 4 or the degree of a polynomial is 4. So you can extend this and come out with a general formula. Well, here is the general formula for the roots of polynomials. So in general, if I write a polynomial in the way given here, let me correct this part. Okay. In that case, the sum of roots can be written as the ratio of the leading coefficient in the denominator and the next term in the numerator, right? So minus of an minus 1 over an, that is the sum. And the product is the ratio of the constant over the leading coefficient times minus 1 to the power of n. So if we have odd degree polynomial, then the product is negative. And if we have an even degree polynomial, then the product of roots for a polynomial is positive ratio of constant over the leading coefficient. Is that clear to you? We just derived the formula for quadratic roots, and you see quadratic roots have only two roots, that is x1 and x2, and the formula will now reduce to minus a1 over a2. The same formula can now be written for product of x1 and x2 as a constant over the leading coefficient. The sign will be positive since quadratic equation is of degree 2. even number. For a cubic equation, the product will be negative since minus 1 to the power of 3 is negative, ratio of constant over the leading coefficient, and the sum is the ratio of negative value for the two coefficients, which are A2 and A3. Correct? We also got one very interesting case, which was the sum of the product of two roots, x1, x2 plus x2, x3 plus x3, x1, and that is equal to positive value of a1 over a3. So that becomes the summary for us. So we do have a general formula and quadratic and cubic roots derived. Now, based on this, we'll have three examples and practice questions for you. Let's begin with the very first example, which is the roots of cubic equation 5x cubed minus 3x squared minus x plus 2 equals to 0 are x1, x2, and x3. Without solving the equation, find sum of the roots, product of these roots, and the ratio 1 over x1, x2 plus 1 over x2, x3 plus 1 over x3, x1, right? So you have to evaluate that kind of an expression. Well, let's begin with the very first one. You remember, for a cubic equation, I've given you all the formulas here. We just derived, correct? So x1 plus x2 plus x3 should be the ratio of what? Well, it should be the ratio of the two terms which are a2, a3 with a negative sign. Negative of this 3, which will become positive, divided by 5, correct? So I've just written here, a3 for us is 5, a2 is negative 3, a1 is negative 1, and a0 is 2. So these are the coefficients. We know that the sum x1 plus x2 plus x3 is negative value of a2 over a3 ratio. Now negative of a2 is given to us as minus 3 and a3 is 5. Writing that, we could get the answer as 3 over 5. The product of the roots, which is part B, is what? Is minus 1 to the power of 3, right? Which is negative, and therefore this is negative. Here, constant over leading coefficient. The constant here is 2, right? Divided by 5 with a negative sign. So negative 2 over 5 becomes the product. Now let's evaluate the third expression, which is 1 over x1, x2 plus 1 over x2, x3 plus 1 over x3, x1. Now let's take common denominator to solve this, right? You get an expression which is, see, the common denominator is x1, x2, x3, their product. Now here we'll get x3, in this case x2, and in this case x1. I've just rearranged. I've written this as x1 plus x2 plus x3, correct? Now, on the top, you get sum, and in the denominator, you get product. So the ratio of what you got earlier is the solution of part C. So that's what I've written here. 3 over 5 over minus 2 over 5, and that gives you the answer minus 3 over 2. I hope that is absolutely clear. Look at it carefully and see how it has been solved. We'll take the next example now. So here is example number 2. We'll just continue with some more. In this case, I am taking higher degree polynomials. Polynomials with degree 4 and 5. And these are the general formulas for you, correct? The sum of roots of a polynomial in general is negative value of leading coefficient being in the denominator and the other coefficient is just next to the leading coefficient. So in our case, when we are talking about degree 4, we are interested in A4 and A3 for the sum of the roots. The values are 3 and 2 respectively. For the product, we are looking for the constant term A0, which in this case is 6. So I have only mentioned the three important coefficients which are important to find the sum and the product, and utilize the formula given to us. Apply the formula, substitute the values, and get the answer. You get the idea, correct? Do the same with degree 5. So when you do degree 5, your leading coefficients a5, and the other coefficients are a4 and a0, which are of importance when you want to find the sum and the product of the roots, right? So use the formula. Remember, minus 1 to the power of n. When the degree is odd, we get this negative sign. Incorporate that in your calculation and check your solution. Is that clear to you? Now, based on this, let's have another example. This example is slightly tricky. We need to find the sum and roots of this equation where the powers are like 2001, 2000, and so on. Have a good look at this polynomial. The polynomial here is 7 x to the power of 2001 plus 2 x to the power of 2000 minus x to the power of 200 minus 5x plus 4. How do we find the sum of roots and the products of roots for such an equation? Well, do not worry. You are looking into only three coefficients. One is the leading coefficient. In this case, the leading coefficient is 7, and the term next to it is 2, which is an minus 1, which is 2. And then the constant, which is 4, to get your sum and roots. The formulas are given here. Perfect. Apply the formula, get the ratio. Well, the negative value of 2 over 7 is the sum. And because the degree is odd, the negative value of the constant and the leading coefficient is the product. Is that clear to you? So I hope that is absolutely simple. Perfect. Well, that brings us to the practice questions for you. So these are 5 practice questions. I'd like you to now pause the video, answer these questions, and then look into my suggestions, right? So if you go through these questions, they're very similar to what we have done just now. Most important things are you have to look into the leading coefficient, the coefficient next to it, and the constant. The leading coefficient, coefficient next to it, and the constant. Leading coefficient, coefficient next to it is missing here. Do you see that part? X to the power of 6 is missing, and the constant. The leading coefficient next to the leading coefficient and the constant. The constant term is missing here. Leading coefficient next to the leading coefficient and the constant. Always consider the sign when you're looking into the coefficients or the constants. The formula which we just derived and generalized is also given to you. That is the set of formula. Apply the formula and then find sum of roots and product of roots. Perfect. And complete your table. So that becomes an exercise for you. Is that clear to you? Perfect. Let's look into it once again. Once you have done this exercise, you can compare your solutions with that of mine. When we talk about the sum of roots, we are actually saying it is negative ratio of n minus 1 over an. But when we're talking about the product of roots, we are saying it is minus 1 to the power of n times the ratio of the constant term a0 over an. Is that clear to you? Perfect. So we have to use this formula to get the answers. Let's write down the answers. Let's highlight. The leading coefficient in these cases are being highlighted. Is that clear to you? Coefficients next to them are minus 2 in the first case, well, plus 3, and here it's missing, right? It's kind of 0. And in this case, it is plus 3, and in the last case, it is plus 2. The constant terms are also being highlighted. The constant term is missing. For example, 4. Missing means it has to be 0, right? That is what it means. Clear. So in the very first case, we have the sum of the roots as the ratio of the adjacent ones, right? So which is minus, because that's in the formula. And then you have minus 2 over 1. And that gives you the value as 2. The product of the roots is the ratio of the constant and the leading coefficient. Power being even, we are expecting a positive value, correct? 3 over 1, right, which is equal to 3. That is how you get your answer. For the next one, the ratio of 3 over 2 with a negative sign is the answer, minus 4 over 2. But since it is an odd, that minus becomes positive, right? So we get 4 over 2, which is 2 in this particular case. Next one here, you see the coefficient for 6 is 0, and therefore we know this has to be 0. And for this term, which is the product, it is the ratio of 1 and 2, right? But 7 makes it negative. So it is minus 1 over 2. Next term here, we have the leading coefficient as 4, next to it is 3. Their ratios with a negative sign is 3 over 4. The constant term here is 0, and therefore the product has to be 0. The last term here, the leading coefficient is 3, next to it is 2, and therefore the sum will be negative value of 2 over 3. And since the degree is even, we are expecting a positive answer. However, the constant is minus 4, so we get negative 4 over 3 as our answer. Is that clear to you? It shouldn't take more than this much of time to do 5 questions. 5 questions in 5 minutes. So once you understand all the concepts, I think it is very simple to find the sum of roots and the product of roots for the equations which we just worked on with. That brings us to the end of this particular video. Here is the formula sheet, which could be very important for you. I'd like you to make a note of this sheet and use it to solve your questions related to the sum and product of polynomial roots. Well, once again, if you really want to learn from me, you can send an email on the address given. Also, check our website for the latest videos. Let me appreciate all of you for watching my videos, posting excellent remarks, and contributing with some very important questions. They make our website unique. Thanks for your contribution and all the best.